Hello, my name is Amy Hunt. I'm a project manager with EA Engineering, Science, and Technology, working out of my house, like many of you are right now, I imagine, in New Hampshire. Thank you for watching our session, which is called Addressing Sea Level Rise Impacts on Environmentally Sensitive Sites. These are sites that can generally be defined as landfills, surplus sites, and brownfield sites. These types of sites have typically been situated at the land-water interface, as this has historically been where much of our industry has been located. Since these sites are also often located in the coastal zone, a better understanding of their vulnerabilities to the impacts of sea level rise has garnered additional attention in the past few years. This session will present the different processes which address the increasing risk to these sites. Our first speaker is Jason Mcnew out of Maryland. Jason is a senior engineer with over 21 years of experience who serves as treasurer for the Sustainable Remediation Forum, or SURF as it's otherwise known. He has a Bachelor's of Science from Penn State and a Master of Science from Johns Hopkins in Environmental Engineering. His focus is on subsurface investigation and remediation, including implementing sustainable components to projects. He's a licensed professional engineer in 15 states, as well as a certified hazardous materials manager. Our second speaker is Caitlin Chafee from Rhode Island. Caitlin recently became the reserve manager for the Narragansett Bay National Estuarine Research Reserve. Prior to that, she worked for 13 years as a policy analyst for the Rhode Island Coastal Resources Management Council, where she developed policy and programs related to habitat restoration, green infrastructure, and coastal resilience. Our third speaker is Chris Overcash from Maryland. Chris is a senior engineer and deputy director of coastal resilience with EA Engineering. He's a licensed professional engineer and holds a master's of environmental engineering from Johns Hopkins University, where he is also an adjunct professor and an associate of the Environment, Energy, Sustainability, and Health Institute. Our fourth speaker for the session is Tabor Midgley from Rhode Island. Tabor is a professional engineer at EA Engineering, specializing in habitat restoration and remediation projects. Tabor received his bachelor's and master's degree in environmental engineering from Oklahoma State University, and he is particularly interested in coastal engineering and shoreline restoration projects that consider the impacts of climate change and sea level rise. Our fifth and final speaker is Chad Sumner. Chad is a co-founder, or the co-founder and managing principal of Sumco Eco Contracting based in Massachusetts. Chad is a scientist by education and training, having received his master's degree in conservation biology and dual bachelor's degrees in geology and biology from the University of Pennsylvania. He has worked in the field at project sites for nearly 20 years and is overseeing the development and installation of the firm's ecological construction and revegetation projects. Again, thank you for watching.
Hello and welcome. My name is Jason Mcnew. I'm the treasurer for the Sustainable Remediation Forum, engineer by trade, doing investigation and remediation. Today I'm going to talk to you about a shift in the way of we're thinking about addressing climate change for environmental cleanup sites, shifting from more of a reactive to a proactive process. So historically, we've always kind of looked at these sites from a reactionary standpoint, where we've had some event occur, such as a hurricane, flooding, some of the things I've listed there, and we've reacted to that. So we've come out to a site, we've done repair on the damage, we've fortified in the event it may happen again, and we've moved on. It's pretty much just been a low frequency occurrence situation where things happen here and there, but it hasn't kind of been a widespread systematic issue over the past 20 or 30 years, let's say. So what's changed? Well, the biggest thing has been the frequency and the severity of what we know. As you can see, there's two graphs there on the right. First one is showing flooding events in some major cities over the last 60, 70 years. What you'll notice is the blue bars there from 2010 to 2015 are showing significant increases in flood events in some of these cities. So it's happening more often than it ever has before, and more severe. And also the big item, the new item, or one of the new items, has been sea level rise. So on the right there, far right, you can see kind of the trends, or the records have shown over the past 100, 200, 300 years even, what we're seeing as far as sea level goes. And the trend is showing a upward tick, and realistically the models are showing that it's going to be more exponential than it is linear. So we're expecting some serious sea level rise that may occur over the next 70 years, let's say. So some other items that are kind of on the quote new threats would be things such as groundwater elevation changes. It's not just coastal, but as we see things moving inward, ground level are going to start to rise, and that's going to affect existing treatment systems, pump and treatment systems, things that are designed based on a known water level. Drought's going to increase as well. We've already seen that happening, which increases the chances of wildfires as well. So there's some, quote, new threats, and they may not be new, but maybe they're more predominant than they ever have been. So that's kind of causing us to change how we're thinking a little bit to address this. And two obvious examples are Harvey and Sandy. Both of these events had significant impacts on environmental sites. You can see on the pictures there, the top left corner down in Texas was a site. The first picture is in the heart of the flooding when it was worst, and then on the right, it's about a week later. We still see a fair amount of flooding. So that was an EPA Superfund site that had to go back and reinvestigate and find out what's been released. The picture on the right and the picture at the bottom are both from some refinery areas down in Texas that had some impacts, where you can see the black, presumed to be oil or some type of petroleum that's gotten into the waterways. So the shift is definitely on. We're looking at a more proactive approach. We're looking at vulnerability assessments now and how we mitigate those risks that we identify. I like the graphic on the right. We're kind of looking forward to the forecast. Still paying attention to what's happened in the past and using that as part of our basis, but really focusing on what we expect to happen 10, 20, 30, 100 years from now. And this is happening on both new and existing sites. We're not just looking at the new sites as we do design work and working that into our designs. We're also going back and looking at existing sites. How can we retrofit those sites to make them more or less vulnerable to the risks that we may see over the next period of time? So what's SURF doing? SURF is a Sustainable Remediation Forum. That's the organization I'm involved in. First thing is we have an initiative that we've established focusing on climate change and resiliency. And the hallmark, or the first big deliverable that we came out with, was that paper that you see picture on the right. It's focused on Massachusetts. It was a collaboration with EcoDAP, a company out of Northwest U.S., and working with the Mass DEP. What it was is a vulnerability assessment or screening of about 6,000 sites in the state of Massachusetts. Through that, we identified about 1,700 of them that have some level of vulnerability, whether moderate or high. It was a screening model, risk screening model, which I'll show you in the next slide, and it did use a bunch of data sets from FEMA, GIS, NOAA, etc. There was a report that came out, and then that report is also available on that link below, and as well as through our website. So this is kind of just a snapshot of the risk table I was talking about. You can see on the left side are some different scenarios from flooding, hurricane, storm surge, sea level rise, etc. And then on the top is kind of the risk, how we scored that based on what it was. And you can see kind of the criteria for each of one of those depending on the feet of sea level rise, etc. and how likely that was to happen. One thing to note there is an environmental justice criteria that was established, which is great to see, because that's something that's probably sorely missed in a lot of sustainability documents from the the social aspects. So that was factored into this as well. So then it output a series of figures and statistics, both statewide and then countywide. This is kind of statewide, showing the number of the 6,000 sites there, all those different dots. They're color-coded based on the severity, so the red is the highest vulnerability of the sites. The good news is that about 60% of them are low or rather no exposure, but the bad news is there's about 29% that are moderate or high. And 40% of those sites, as it says on top there, were subject or likely to be exposed to flooding or future sea level rise. So a lot of sites, a lot of things to consider for the state up there. So what else are we doing? A big contributor to the ITRC SRR team, Sustainable and Resilient Remediation team. We have a lot of folks from SURF that are operating in that. They're putting out a document. It's due out the end of the year. It's going to provide resources to a bunch of folks to kind of help them figure out how they can integrate these type of practices into their projects. It's updating a 2011 guidance that was put out by ITRC. And the big factor on this, or big extra to this, will be incorporating climate change resiliency, notably wildfires, sea level rise, etc., that were not really in the 2011 guidance. We weren't really up to speed back then. So that's a big part of this and the big driver for the update. And then there's a lot of recommendations in there to not only look at the environmental footprint and costs and benefits, but as I said, incorporating the social and economic side of things. So it's a balancing act, and that's what this guidance document is really trying to do. So this is kind of a draft idea of what we talked about in the team. I don't know the final product yet, so definitely consider this draft. But the idea is having something like this with clickable boxes that would take you to links or take you to guidance or take you to BMPs or something along those lines based on the different topic, whether it's you're looking at what do I do in a certain life cycle or a certain spot in the life cycle of the project. What do I do if I want to develop a site model? Where are the different, I'm in the RI stage or I'm in the remedial design stage. What should I be considering then? I'm looking at risk management, so it's broken down by topics, life cycle, and kind of will hopefully be a roadmap for you to figure out where you can get information based on what you're looking at. And then another idea is something along these lines where it's going to be like a best management practice checklist where you identify your factor you're looking at, and that'll kind of tell you what checklist or what things to consider. So changes in precipitation. If you're going to see more rain, you're going to expect more flooding and bank erosion and maybe snow or hail, depending on where you're at. So that's where you would want to go and look at those different best management practice, figure out how you can mitigate that through your site. On the opposite, less precipitation is going to bring you drought, etc. So you can see there's a couple things there with temperature, precipitation, water, change in water levels, which we talked about earlier, the groundwater, and then some other factors too. Are you going to get more wind, which could have impacts on some of your sites, or wildfires? So the idea is make this simple, make it clickable, make it easier to find, easy to understand, and really help folks to implement these. Not only folks that do it every day, but maybe people that aren't as aware as a part of an education too. So future plans, what do we need or what's needed? I think one of the biggest things we need to develop a more robust vulnerability assessment guidance. I don't think one exists really that is kind of going around from a site remediation standpoint. I know there's a lot of tools on how we mitigate, but how do we score these sites? How do we evaluate these sites? Kind of taking what they did for that Massachusetts and make it more on a site-by-site basis. And then take that Massachusetts study and expand it to other states. There's a lot of coastal states that could really use this document if it's not already been done, or the screening if it's not already been done. Take the lessons we learned from that one and start to implement this or apply it to other states to do a similar type of study. Get the ITRC document finalized, hopefully again by the end of the year, and get that distributed and folks looking at that. Integrating into our planning is a big key, right? It's how do we get this in the project planning no matter where we are, what phase we are. How can we start to look at this, whether we're in the initial planning or whether we're in the back end where we're design, or even after we've already implemented. As soon as we can get that in, the better, but there's always an avenue to do so. Getting stakeholders involved is always critical for any project, but even more so for this because of the idea that there's maybe a lot of people aren't thinking this way. They aren't thinking future necessarily. It's hard for folks to maybe see these things without it happening, but now as it happens more and more, I think awareness is getting out, and that's the last thing, is really increasing that awareness, making folks outside of our little bubble that understand this and start to support it, and it's not just a secondary thing, but it becomes a primary consideration, with the goal of obviously trying to minimize the impacts from all these different events that's happening over time. And then that's the hands at the end is you. It takes folks, volunteering and putting time into this to build this. So I know at SURF, we're always looking for folks, and a lot of these other organizations are looking for people to volunteer and help out. So that's what I think is going to take to be successful, combination of all those things. So that's what I had. Thanks for checking this out and listening. If you're interested in SURF, some information on this slide. Check us out on the website. We do have LinkedIn. We put out a newsletter. You're welcome to email me anytime. I'd be happy to tell you more about it. And thanks again for listening.
Hi, my name is Caitlin Chafee, and I'm the Reserve Manager at the Narragansett Bay National Estuarine Research Reserve. Until recently, I was a policy analyst at the Rhode Island Coastal Resources Management Council. And I will be talking today about a case study for addressing coastal hazard impacts to environmentally sensitive sites. The case study is the New Shoreline landfill, which is located on Block Island. Special thanks before I begin to Cassandra McKenzie at the Department of Environmental Management, who provided a lot of the information for this presentation. So the site location is on Block Island, which is off the south coast of Rhode Island on Block Island Sound. The site itself is on the northwestern shore of the island, adjacent to the Block Island National Wildlife Refuge. Here's a closer view from an aerial photo where you can see in the bottom left, the area in the square is the buried landfill, and the site is still an active transfer station. It's a total of about 10 acres on 3 different parcels. And you can see also in this photo the adjacent freshwater pond and freshwater wetland complex. The landfill itself was in operation from about the 1900s to January of 1990 as basically an open dump for household waste, demolition debris, etc. It was listed on the DEM CERCLA list as SFA, which meant that it was on the EPA Superfund CERCLA list with a status of active. And I've just included the site number and project date for that reference. The site is adjacent to several sensitive environments, which are listed here. One already mentioned is the National Wildlife Refuge to the north. There's some federally endangered species habitat, some state listed species habitat. It's adjacent to state designated type 1 waters, which are conservation areas that are designated by CRMC. And it's also, the site is also part of the federal coastal barrier resources system. And again, it is right next to that freshwater wetland complex. Block Island itself has been named one of the Western Hemisphere's last great places by the Nature Conservancy, which manages over 2,000 acres on the island for conservation. So again, the site, the area of landfill in question, and you can see that within the context of the natural areas surrounding it. So in 2015, there was a CERCLA site assessment that was performed on the site. Just some interesting results from that assessment of note. A few of the soil samples exceeded state residential exposure criteria for metals and PAHs. There were some test well samples that exceeded residential limits for some metals. And then mainly what was observed was the solid waste debris on the western shore of the landfill where the shoreline was eroding. So things like auto parts, ceramic and clay, plastic and metal. It was also noted in the assessment that there is no percolation containment present, which means that contaminants are exposed to ground and surface water pathways. That assessment was done after 2012 when Superstorm Sandy hit Rhode Island, and the storm definitely exacerbated the erosion that was occurring on the western shore of the landfill, and you can see evidence of that here in this photo that's provided by Janet Friedman, our coastal geologist. So you see some of the erosion that's occurring, some of the solid waste materials that are beginning to spill out on the beachfront. More of that here. So several different types of materials. So for that reason, the town of New Shoreham applied to CRMC and other agencies to remediate the eroded slope in 2016. They submitted to us an alternatives analysis performed by a consultant that looked at several options. A few of the options suggested using geotextile sand containers and creating a 2.5 to 1 slope and removal of varying amounts of the solid waste. Eventually, what the town selected as the preferred option was the construction of a stone revetment with a 2.5 to 1 slope and removal of 7,000 cubic yards of material, which came in at a price tag of $2.18 million. The geotextile sand containers were slightly more expensive. One option was to just use those containers. That was $2.35 million. Another option combined the GSCs with stone for a price tag of $2.44 million. And then there was another option that was looked at for removal of all of the landfill contents, which would mean excavating, transporting, and disposing of about 900,000 cubic yards of solid waste. And that had a very hefty price tag of $20.7 million. That was well beyond the resources available to the town. at the time. The consultant also looked at the no action alternative, which was dismissed because addressing this landfill issue was an action item within the town's hazard mitigation plan. So the town had already recognized the need to act to remediate the situation. So the no action alternative was rejected. In terms of permitting, the town was required to go to the Department of Environmental Management for a limited action remedial approval letter. They came to CRMC for a coastal ascent, which included the need for a special exception, which meant that they needed an exception to a prohibition in our program, which was basically creating a structural shoreline adjacent to type 1 waters. To get a special exception in our program, you need to meet several criteria, one of which is that the project serves a compelling public purpose, which it was determined that this project did. They also needed to consult with the U.S. Fish and Wildlife Service regarding the Coastal Barrier Resources Act. They needed an exception to that act, which was granted. When those permits were issued, there were several stipulations that went along with them. In terms of the DEM permit, the town was required to submit a remedial action work plan to bring the entire site into compliance, and they were required to submit a draft environmental land usage restriction for the site. For CRMC, they were required to commit to monitoring of the revetment ends for erosion impacts. They were required to provide for public access by installing a public access pathway. It included requirements for soil stabilization measures during construction. And the town was also required to submit a long-range landfill remediation plan. And while the preference of both agencies was to see the entire landfill contents removed and relocated and reinterred, that was well beyond, as detailed before, the financial resources of the town. And so a compromise was reached that the town would implement a long-range plan to maintain the slope and remove material from the landfill over time. What helped in the development of those provisions was the fact that the CRMC has very detailed information about erosion rates along the Rhode Island shoreline, including Block Island. These maps have been created by Dr. Brian Oakley at Eastern Connecticut State University, and they're very helpful in that they have perpendicular transects which show the average annual erosion rates for areas of the shoreline. And so these are the transects adjacent to the site in question, which show an average annual erosion rate of about 1.6 feet per year up to 3.2 feet per year. And so our permit staff were able to consider this when making recommendations about what needed to happen over time as far as material removal. And so basically they determined that over a 15-year period, the site was likely to see erosion of up to 45 feet, so a loss of 45 feet of shoreline. And so the town would need to prepare for that and be willing to remove any material exposed over that time frame. Another helpful tool was our storm tools maps, which are high-resolution maps of storm surge and sea level rise modeling that have been done for the entire shoreline of Rhode Island. And so those helped in checking the calculations for the design elevations, looking at what the significant wave heights were likely to be at this site. Interestingly, the significant wave height detailed by storm tools is a bit higher than what is noted on the FEMA V-zone maps. And so that information was very important, and it was determined that the engineer had adequately accounted for the significant wave height. And really the design was to withstand a 100-year storm. When it came time for construction, unfortunately the town lost some federal funding in the form of a community development block grant that they had been counting on, so the project unfortunately needed to be scaled back. Originally, the revetment design was supposed to be 20 feet in elevation. It wound up being reduced to 8 feet with 3 to 10 ton stones. The resulting slope was originally supposed to be a 2.5 to 1 slope. The design was changed to a 3 to 1 slope, which was to be covered with sand and loam and planted with beach grass. According to the town's engineer, the estimated lifespan of the structure is about 15 to 20 years, which is why that was the time frame for the incremental maintenance plan and removal plan. The town secured a $2 million municipal bond to fund the project, and in total, about 120 tons of scrap metal and trash were removed to pull the toe of the slope landward approximately 50 feet. This is just the engineered plan for the site. It's not zoomed in very far, but you can see the major project components on the western side of the site here as being the toe revetment, stone revetment, and then the slope, which is covered in loam and sand and vegetated. And here's just a cross section showing that same thing, the toe of slope stone, a 3 to 1 slope here, and the vegetation. These photos, I believe they're drone photos, were supplied by the Department of Environmental Management of the finished product. The work was started in 2018. I believe it wrapped up in 2019. So this just gives you an aerial shot of the finished project. Where the people are walking is where the required public access path was installed. Here's a shot looking south. You can see the revetment, the planted slope, and then the landfill behind that. And the clearly marked public access trail. And here's a shot of the entire site, including the transfer station and the wetland complex to the north. Just a couple things I wanted to note at the end of this presentation were that having those detailed erosion rate maps and the high resolution sea level rise and storm surge modeling were very helpful to CRMC permit review. It helped our permit staff to make recommendations that made sense. Lateral shoreline public access is always an important consideration for CRMC when permitting shoreline structures because of sea level rise impacts. So where it's safe to do so, we want to make sure that there are provisions for preserving public access, which was done here. Future considerations may certainly need to consider include impacts to groundwater. As sea levels rise and the water table rises in this area, there may be additional impacts to groundwater quality from sea level rise and saltwater intrusion. And another main point is that this site was unique in that it was located on an island, which represented unique challenges to the construction process, certainly large costs that were associated with transporting materials on and off island, which really affected the alternatives chosen. Thank you to the folks who contributed to this presentation. Again, Cassandra McKenzie, DEM, my colleague Rich Lucia at CRMC, and Jim Jeremia, who's the town engineer for New Shoreham. I've included my contact information. You can feel free to contact me with any questions, and thank you for listening.
Yes, hello everybody. My name is Chris Overcash, and I'm the Deputy Director of Coastal Resilience for EA Engineering, Science, and Technology. And the next project we'd like to discuss with you is in regards to planning for coastal resilience in northern Chesapeake Bay, and we'll be dialing into environmental considerations for that project. So just as a quick background, this planning study was completed in 2019 for as a joint land use study for the Office of Economic Adjustment, Department of Defense, focused on a few different areas, Aberdeen Proving Grounds in Maryland, as well as the surrounding counties. In the framework, as you can see on the left, was dictated by certain steps, and I'll be going through those as we quickly discuss the project. So the first item is project scope identification. And in the case of this project, we were focused on a lot of different perspectives. And so as it applies to the context of our discussion at the conference, Part of that were environmentally sensitive areas, including landfills, state designated hazardous sites, as well as surplus sites, brownfields, as well as military ranges, which involved unexploded ordnance issues. And you can see the rest of the encompassing items that the scope addressed, including other environmental areas as well as infrastructure impacts created by the particular project for coastal resilience. So the next item for the project was to identify climate impacts. And this would be similar to any climate resilience project in that you have to identify the potential impacts. And for us, we were looking at mostly at coastal impacts. And you can see the main three components here. So it's not only sea level rise, but potential impacts from precipitation as well as associated storm surge with large events. So the first item to realize in a project like this is that there are many different data sets. So for our particular site in Northern Maryland, there were several items that we looked at. And basically, you can see here, sea level rise projections from 2018 were directed at a worst case scenario of about 7 feet for the high range. We also had storm surge indicated and precipitation for the area. So once that is identified, the next step is to identify climate vulnerabilities. And for this project, we looked basically at a GIS-based model tied into those sea level rise components. So you can see here, this is a map of Aberdeen Proving Grounds, which is one of the lowest lying areas in Chesapeake Bay. So we could expect significant impacts to the end of the century. You can see here just an example of some of the visualizations of our project, current conditions at Aberdeen Proving Grounds. And then as we move through the century, you can see this is 2100 mid scenario, shows a 2.3 foot increase, but also if you add the major flood stage to that, it inundates further areas. And then worst case scenario, as you get closer to 2100, you can see significant flooding components on this portion of Aberdeen Proving Grounds. Just as a comparison, the other areas within the county had more elevation. So this is actually Havre de Grace, Maryland. You can see because there is significant topographic elevation in the town, you can see it is impacted to 2050 and 2100, but it's mostly contained or in the coastal zone for that town. So once you've identified the climate vulnerabilities and they're specifically identified, you moved to the strategies and measure of options that could be brought to bear to protect coastal areas. So when it comes to that, you're talking about a framework of three different ways to proceed. Accommodate would be to alter existing structures to be able to withstand those climate impacts, in this case, sea level rise. Protect would be using heavy or hard engineering solutions to protect areas, including areas with environmental contamination. And third, manage retreat, relocation of structures in areas from those particular zones. Now that becomes problematic if you're talking about managed retreat in the context of contaminated sites, because obviously you would have to remediate those sites or they would still be impacted in those future conditions. So within our report, we identified the potential solutions for these various impacts, and they were defined, as you can see here, in three different areas, three different ways to provide that resilience: natural, non-structural, and then structural. Just to touch on what some of these are in more detail, structural or nature-based measures to protect these areas include reestablishing or increasing dunes or beaches in an area. Vegetated features also provide extra protection, such as wave attenuation. So you're talking about increase of coastal marshes, submerged aquatic vegetation. We also looked at potential restoration of barrier islands that can also obviously dissipate wave energy. And then another key item, maritime forest and shrub communities also provide some of that extra resilience. So, this is one of the first things that we looked at for potential solutions in these areas of impact in northern Chesapeake Bay, the nature-based measures. Next, there are obviously non-structural measures you can proceed with, such as changing floodplain policy and management. This can have significant benefits later on in the century if you start implementing them now, so that people start moving out of those danger areas. In the case of contaminated sites, that would also be the case. Gives you more time in planning to remove the constituents of concern from those areas. Floodproofing and impact reduction is also a solution, and obviously relocation is possible in certain situations. Then finally, structural measures. So these are items that folks would probably be deferred to when you think about solutions to coastal flooding. So hard structures like levees, even storm surge barriers, seawalls, and revetments that can provide that shore armoring in situations where a specific area has to be protected. These are sort of a last resort in particular areas. So once you have possible measures identified, the next is to then use those possible measures and adapt them to a specific plan for an area. And some of the keys there, as we talked about before, obviously timing to these coastal impacts is going to be based on how quickly sea level rise occurs. And it's also based on criticality of areas, such as if you have unexploded ordnance in an area, how critical is it to move forward with that quickly. So again, timelines on when to execute these measures are based on criticality, your specific identified strategies and measures, and then looking at adaptive design considerations, such as seawalls can be designed to be added on later. So to make sure that your base design for a seawall that you might construct just to 1 foot by 2050 could be raised to 3 feet, say, by 2100. And also, it's key to understand the study horizon. What is your target study or your target date for completion? Another important consideration is that there are many grants available for this type of work. An example was for this project, we had a follow-on project with the city of Aberdeen, which is adjacent to the base, to complete a full assessment of climate adaptation. And we actually looked at using dredged material to provide that coastal resilience and protect that town and some of the environmentally sensitive areas there. So again, just to reiterate, there are many grant platforms available for this type of work. And this is just a list of some that were available in the Chesapeake region and some on the national basis as well. And we'd be willing to talk with you about potential funding mechanisms if some of these thoughts may help with your particular situation. So thank you very much for your time, and enjoy the rest of the conference.
Hello, and welcome to my presentation on assessing the resiliency of the Satchos Point Remediated Landfill. My name is Tabor Midgley, and I'm a project engineer with EA Engineering, Science, and Technology out of our Warwick, Rhode Island office. A quick point about the cover photo here. To the left, we have Satchos Bay and Second Beach. Down the center is Satchos Point Road, and the elevated topography to the right of the road is the Satchos Point Remediated Landfill, which we will be discussing. A quick, brief site introduction. The project is located on the Satchos Point National Wildlife Refuge, which is on the southeast tip of Aquidneck Island in Middletown, Rhode Island. It is 242 acres, sandwiched between the Rhode Island Sound to the southwest and a Seconic River tidal strait on the northeast. Newport can be seen in the background, with First Beach off in the distance, and Second Beach and Third Beach immediately adjacent to the refuge. Finally, we have the Visitor Center directly in the center of the photograph. This is part of the larger U.S. Fish and Wildlife Service Rhode Island National Wildlife Refuge Complex and supports important wildlife such as New England cottontail, harlequin duck, saltmarsh sparrow, and over 200 other seasonal bird species. Important habitat types it supports is shrubland, cobble beach, and saltmarsh. In summary, this is a popular destination for tourists, it provides unique habitat, and is important for various species. Today we will be talking about the Remediated Landfill, which is located here adjacent to Second Beach. So the landfill is approximately 15 acres, located very close to Satuas Bay. A brief history, it was subject to unregulated dumping as early as 1951, operated as a municipal landfill until 1973, then a transfer station for a couple years. Waste operations finally ceased in 1975. It was subject to CERCLA investigations between 1994 and 1997, when it was classified as a low priority, and EPA recommended no further work done unless recommended by RIDEM, the Rhode Island Department of Environmental Management. Accordingly, a site investigation report was prepared under RIDEM regulations in 1998, and a remedial action work plan followed up in 2003, with the remedial action being completed in 2005. As you can see in this historic aerial, the red circle to the south is the high fill area, or basically the current footprint of the landfill. To the northeast of that is what we call the low fill area, which also had waste. Part of the remedial action was relocating that waste into the high fill area, which was then capped with several soil layers and then a polyethylene liner. Stormwater and gas venting systems were installed, and the low fill area was restored as a tidal salt marsh, as you can see in this aerial. To briefly discuss the contaminants of concern within the landfill, there's widespread distribution of several chemical compounds, including PAHs, pesticides, PCBs, hydrocarbons, and metals. These are at relatively low concentrations, but there are exceedances of regulatory and guidance levels in several media. This is very typical of constituents found in landfills that operated in this time period. Lead is the primary concern as it consistently exceeds RIDEM criteria in more than one media. Under current conditions, the landfill generally poses little risk to human or ecological receptors because it is closed, or so we thought. In 2012, Superstorm Sandy made landfall on October 29th and was rated between the 10 and 25-year recurrence interval event by the time it made landfall in Rhode Island. As you can see in this photo, Satuas Point Road was completely undermined and made impassable. That is the visitor center off in the background. The landfill itself was covered in debris and beach sand. Post-Sandy, repairs were made, which consisted of slope armoring, road reconstruction, and reinforcement of the landfill toe. I have this photo here, which is present-day Satuas Point Road, looking in the opposite direction, but you can see the slope armoring to the left. There's also toe armoring at the toe of the landfill to the right, which you can't really make out, but it's there. So, as a result of Superstorm Sandy and the encouragement of the town of Middletown and the U.S. Fish and Wildlife Service, EA was selected to evaluate the landfill cap as to its vulnerability now and into the future to damage associated with storm surge and catastrophic weather events. Data and models we've utilized included the 2015 North Atlantic Coast Comprehensive Study, the Wave Height Analysis for Flood Insurance Studies, WAFIS, and Run-Up. So some of the data that we relied on included USGS topobathymetric elevation model, which was conducted, or data was recorded for it after Superstorm Sandy. We also, as I said, use the comprehensive study results for the 100-year average recurrence interval storm event, which provided the still water elevation and significant wave heights for whatever storm event we wanted. For this evaluation, we used the 100-year event. And finally, for sea level rise, we used, consistent with state guidance, we used NOAA's 2017 high sea level rise curve and evaluated 4 different time periods, present, 25 years from now, 50 years, and 75 years. As you can see in the photo, this is the comprehensive study locations within Satchwas Bay. There's 10 locations within the bay itself. We really focused on the 3 there, which basically form a perfect cross-section right into the landfill. Here we have some of the wave height data. So with a comprehensive study, a significant wave height of 17.1 feet and a wave period of 11.4 seconds. Then we edited the data for WAFIS and run-up to calculate the waves, overland waves, and wave run-up on land. So for sea level rise projections, I just wanted to give this table to show what magnitudes of these that we ended up using. As you can see, we have in the 4th column, we have mean sea level. So 2018 is 0.6 feet, 2.2 in 25 years, 4.5 in 50 years, and so on. And we also have the 100-year still water elevation, which is significantly higher. So I just wanted to note some of the methods and limitations of this study. Basically, the 100-year storm characteristics predicted by the comprehensive study were applied as is to each sea level rise projection. In other words, if we had a significant wave height from the comprehensive study, that significant wave height was the same no matter which sea level rise projection we were evaluating. However, in actuality, as a result of climate change, those characteristics may change along with sea level. For WAFIS and run-up models, they were developed only using a single coastal transect, which you can see in the figure on this slide. However, the coastal zone in this area is relatively uniform, so it should be pretty representative. And finally, we only evaluated waves from one direction, the southwest. However, this is perpendicular to the shoreline and landfill, which therefore energy transfer should be the strongest in this direction. And also the southwesterly direction has the largest fetch and is generally the worst case scenario. You can see here also on the figure the 2018 mean sea level, the kind of the cross-section, the Bathian topographic data. You can see the Satchwas Point Road and the armoring at the landfill and the landfill itself. So, results. This first chart shows the 2018 results, so present sea level rise. At the bottom of the chart, we have mean sea level at 0.6 feet. We have Satchwas Point Road, the yellow, the landfill riprap at the toe of the landfill, and then the landfill the rest of the up to the peak. The 2018 still water elevation is at 13.4 feet. So even without waves during a 100-year storm event, the road and the landfill armoring are submerged. When you start including wave setup and wave envelope, we are experiencing energy transfer onto the grass cover of the landfill, directly onto the cover, the unprotected cover. And this is without sea level rise. I'm not going to show the 25 and 50-year results because they are just steps in between the 75-year results, which I'm showing here. Basically, in 2093, mean sea level is basically at the road or higher. The storm elevation, still water elevation for a 100-year storm is nearly towards the top of the landfill and waves completely overtopping it. So we also evaluated existing cap vulnerability. As we saw during Superstorm Sandy, anecdotal evidence indicates that storms below a 25-year event can impact the toe of the landfill slope, as we saw by the debris being distributed across the landfill. EA evaluated the vulnerability using Army Corps of Engineers methods, and we found an overtopping discharge right at the top of the armoring of 175 cubic feet per second per linear foot. When converted to a velocity, this greatly exceeds the allowable flow rate of grass cover and indicates that significant erosion would occur. It was, however, determined that the stone armoring was sized sufficiently to handle velocities, just not placed to the elevations required. So, conclusions. The Satchos Point Remediated Landfill is susceptible to coastal storms. Under present-day sea level, the landfill cap will be impacted by a 100-year average recurrence interval storm event, potentially eroding soil, damaging the liner, and releasing contaminated material into the environment. These impacts will only be exacerbated as sea level rise continues. In fact, with present-day sea level, the cap is already vulnerable to storms less than the 100-year ARI. As sea level progresses, the ARI that threatens the unprotected portion of the cap will decrease, meaning as sea level rise progresses, smaller and smaller storms will pose greater and greater threats to the landfill cap. So, solutions and path forward. We are working with the U.S. Fish and Wildlife Service now to perform an engineering evaluation and cost analysis on several alternatives. A quick summary of our remedial action objectives include taking preemptive action to protect human health and natural resources, preventing mobilization of landfill debris and contaminated soils, preventing mobilization of contaminants into groundwater, minimizing the resources needed for repetitive maintenance, and maintaining and improving ecological habitats at and near the landfill. Our preliminary alternatives include additional landfill armoring, nature-based surge protection such as a beach dune system, and partial or complete removal of the landfill with off-site disposal. So, in final word, this project has demonstrated that this remediated and closed landfill is susceptible to large storm events and sea level rise. It is very important to note that this is just one example. There are many active and closed hazardous and contaminated sites across the country in the same situation, and something that we need to evaluate. Thank you for your time. Please feel free to contact me if you have any questions.
Good morning, good afternoon, or good evening. Restore America's Estuaries participants. This is Chad Sumner. I'm a principal with Sumco Eco Contracting, and I'm just going to take you through a couple of coastal construction case projects that we worked on. These are remediation in the coastal and estuarine environment. They are by no means the largest projects. This is not a multi-acre, 1,000-acre Superfund site in a salt marsh setting, but it is indicative of a multitude of projects that occur along our coastlines and along our estuarine lines. So one thing I want you to key in a little bit as we're looking through these slides of the construction phase of these projects and the afters is thinking about water control during construction phase. So I'll touch on that briefly as we go through it, but then also recap at the end of the presentation to offer some thoughts on that. So the first project we're going to look at is the Water Street Brownfield Redevelopment project in Plymouth, Massachusetts. This is leading up to Plymouth's 400-year anniversary. A lot of work going on in town to get things shored up. This site was contaminated with petroleum hydrocarbons and PAHs, jumbled down revetment system, so Phragmites on the bank. Clearly there was some armoring at one point, and I know this is going to make most folks at this conference cringe when we look at another armoring solution. The issue here was a pretty abrupt elevation change. Typical permit conditions driving design where didn't want to extend into the resource area, into the high tide line, which you can see there. A very recent one, certainly not necessarily mean high, but most recent high, and trying to retain that armoring and stabilization structure within a narrow footprint from parking level down to the high tide line. Also, it was a contaminated site, so significantly less engineering tolerance for failure there, because we're trying to retain those contaminated sediments or contaminated material in the upland. So scope of this, typical contaminated site, DEP file numbers, EPA Brownfield grants, everything else. Green soils are not necessarily native soils, so it needed to get out those hot spots. So there was certainly a degree of contaminated material that needed to be excavated, removed from the site, and backfilled. Nothing atypical about that dig and haul type remediation system. But then as we start working into the coastal environment, obviously some very large rock that went in, again, cringeworthy. I know, I apologize for the audience here, but what was designed and engineered for this particular location. So excavated down, had the orange marker layer to identify where the limits of contamination were, should that get exposed in the future, an indication that something needed to be done to reconsider that coastal bank. So working that revetment along that 200 linear feet of shoreline, plus or minus. And in this case, we're not looking for a smooth jetty type structure. They were looking for more of a natural, well, I shouldn't say natural, but more irregular surface. You can see that the top elevation there is fairly consistent across the site, the design elevation for that structure. So then working back from that revetment structure, we have the orange marker layer, again, extending into the site over the top of the lower level contaminated soils that were remaining in place, up by the excavator, the marker layer there, and then a bedding material of reclaimed asphalt. And then within the site, from a stormwater standpoint, this is a parking lot, so they actually used a bioretention facility. So we've got the orange marker layer, again, over the contaminated material that was replaced, or contaminated soils that were remaining in place, lower level. That's the under drain trench that runs along the bottom of the bioretention area. We got a focal point in drop inlet within that retention system as that bioretention basin fills up to drop into there. And then a finished condition. So, again, here, this is not necessarily, this is not our long-term forever situation here. You can see that the revetment that was there before was tossed around a bit over time. Parking areas, repaving. This is not necessarily a nature-based solution, but it is downtown Plymouth, and it's a resource to the town, something that will need to be maintained over time. Some uplift to the site in that the higher level contamination was removed. There's a resource for the town with the parking, better management of the stormwater system. So that was the outcome of this project. Slightly different variant on that is the Senator Joseph Finnegan Port Norfolk Park Remediation Restoration Project in Dorchester, Massachusetts. This is on the Neponset River estuary, so this is actually up into the estuary on the Neponset River, where the Plymouth project was located, right on Plymouth Harbor. So a bit more exposure to particularly northeast storm events that we hear a lot about up in our area. In Dorchester, the solution here was primarily the concern was lead contamination. So we did have some areas of hazardous level lead that needed to be excavated and removed from the site, as well as a couple dump sites with asbestos tile. So that soil was remediated as well. But the overall existing condition for the site was 12 acres of impervious surface. So this was asphalt concrete associated with the Schaefer paper mill and subsequent iterations of the industrial use of the site. And rather than going with a hard solution here, we were able to employ some nature-based solutions on the coastal environment, as well as rather than full hardtop impervious surface again, we're able to cap the residual lower level lead contaminated soils with 2 feet of horticultural soils as the cap, and install a passive park over at the top of it. So, I mentioned being able to use some bio-based solutions, nature-based solutions. We actually had a pretty expansive area of high marsh growing on top of the asphalt that had been left there following the removal of the industrial facilities. So salvaged that salt marsh sod, found a couple appropriate elevations along the perimeter of the site where we could place that as part of the restoration effort. A couple other areas where we had a steeper profile, put in some fabric encapsulated soil lifts. You can see the core log down at the bottom of the picture there. Those timbers were removed down to grade, but we didn't go subgrade, so allowed for those to provide some additional stability of the toe for that system. And then that entire length was planted with appropriate elevation marsh species and coastal bank species as part of that bio-based solution, nature-based solution for the perimeter of the site. Then working up into the site, seeded the balance of the area, put in some pocket plantings. These are native seed mixes, some more turf-based grass seeds, as well as meadow and forb mixes that were designed for the site. Pretty tight specifications for the soil mixes that went in there as well. So at the end of the day, we've got a passive park, part of the Neponset River Greenway. You can see some houses in the lower left picture there. That's the Dorchester neighborhood of Boston, where before those folks had been looking at Japanese knotweed, Phragmites stands, impervious surface, and it really just no view or real sense of where they were relative to the river. Now have view lines to the Neponset River, walking trails, passive park. And so really a significant uplift for that community and that smaller neighborhood of Dorchester, this component of the Dorchester neighborhood in Boston. So very nice outcome there. And this picture is set more for context of what I'm going to talk about a little bit related to the water. So this is during a spring follow-up inspection. The tide rack line was actually running through the middle of those three birches that you see in the middle of the scene. So while this was very much an upland remediation restoration site, passive park, this was the year following. We had 3 or 4 really solid nor'easters up in the Boston area. Made the news. The Seaport District was flooding, and so while this is an upland remediation, even here in 2020, we're seeing some pretty significant events that are pushing water across sites like this. So if we then kick this forward, and what I was talking about at the beginning, mentioned taking a look at the water control during construction phase, really there wasn't any, right? Because all of these were designed to, other than the fringing components of this site where we're working intertidal, all of this was upland restoration, upland remediation, site development, site restoration. So kick this ahead 20, 30, 50 years, and this is very possibly an intertidal zone. We may be talking about high marsh species versus turf species. So we do have this window for a lot of the sites like this, depending on how forecasts play out relative to sea level rise, where it's going to be a lot easier to do these projects now than it will be 50 years from now. And we also, as we think about the lifespan and longevity of some of these projects, thinking about what these might look like. And so where this site certainly allows for some migration of those species, we've got a big open passive soil surface site. This could very well become salt marsh over time. Where the project over in Plymouth, we've got an impervious surface revetment stone that from a resilience and a long-term longevity standpoint, very different than this one. But we do have this opportunity right now to be thinking about where sites like this can be advanced, where we can improve on that system and provide some uplift to the neighborhoods, to the estuaries, address legacy contamination before it becomes part of our intertidal estuary environment. So that's what I wanted to throw out on this one. A couple interesting projects there. Hope you folks all enjoy the rest of this virtual conference, and feel free to reach out to us any questions about this or related projects. Thank you very much.